done. Okay, very good.
So there is a change in our program, but so you can.
So my student Aditya was supposed to be doing this, and he was supposed to be doing it here, but unfortunately our state in the United States is not doing well, and they wouldn't allow students to travel from our university. So I'm going to give the talk, and he is, I think, online and can answer some questions if that comes up.
Okay, very good.
So this talk is going to cover primarily aspects on work we've been doing over the last maybe 8 to 10 years. And the goal, if you saw Herman Ney's presentation, keynote talk earlier today, obviously a lot of the machine learning, deep learning strategies require massive amounts of data. And in most academic circles, it's very hard to get access to real data. Even if you're getting stuff from YouTube or other places, it tends to not be consistent and very non-uniform. So our goal in this effort was to see if we could get access to very, very large amounts of data and to try and see if we can make that publicly available to everyone. And there's always issues, for example, on privacy and other things of this nature. So with the help of the National Science Foundation, we received an initial project to recover a small portion of Apollo 11 data. And this past year, NSF awarded us a follow-on grant, which is set up for community engagement. And so we collected 19,000 hours of data in the first project. The second project is going back to get all the remaining Apollo mission data, and that will exceed upwards of 150,000 hours of data. So all of that's going to be made publicly available, all transcribed, at least automatically, and tagged for speaker and texts for ASR type applications, with the hope that there'll be a community of people that can kind of use this. So title of this talk has actually been on the Fearless Steps Challenge Phase 3. Aditya is my student and kind of the person that's been leading this. This year we were very fortunate to have collaboration engagement with both NIST and LDC. At NIST, Omid Sadjadi, one of our former students, but now is involved overseeing some of the speaker and language ID stuff from NIST, participated and helped us greatly. And Chris Cieri from LDC also involved. So actually, I think the slide goes here, right? Okay, so outline here, just a brief review of the Fearless Steps Challenge series. We'll talk a little bit about what was involved with Fearless Steps 3, what were the differences between the 3 challenges, the challenge portal, overview of the data sets for Phase 3, conversational analysis task, which was a new task we added for protocols and hotspots for conversational parts to see if we could find areas where issues were difficult for mission control at NASA to kind of deal with things. And challenge tasks and baselines for the pieces. So the challenge results, we do have results obviously for the participants that went through this, and we also have an evaluation subset. And just to remind you, everything here is publicly available. You can download everything. Baseline systems, we make those available. The language model lexicon, we make that available as well. If you're using Kali, we have recipes for Kali that we use. Okay, so Fearless Steps Challenge 3, or Phase 3 there, was to evaluate spoken language technology system generalization and to see whether it can adapt to maybe unseen channel or mission variabilities. And this is something that we see for the Apollo program. The 5 challenges had speech activity detection, diarization, speaker ID, speech recognition, and then conversational analysis. Those were kind of the 5 broad categories. There were some variations in each of those categories. For the diarization side, we looked at cases where diarization using a system speech activity detector and one using a reference speech activity detection system. So this way you could remove that to see whether things were working better. For the ASR task, we also looked at undiarized audio streams and ASR with diarized audio segments. So this allowed you to look at trade-offs there. The other part also is we wanted there to be a low entry barrier. If someone wanted to kind of look at a new task, and didn't have the resources to do other pieces, that they could kind of jump in and try to work that one part. Detecting conversational hotspots was kind of the new task. We really wanted to see certain things that were important in here. And just keep in mind that if you've listened, anyone over maybe the age of 40 probably has heard that. But if you're under the age of 40, you probably have at least heard Apollo audio at some point. But all the audio you may have heard would only have been stuff that was released publicly. And that comes off typically the capsule communicator or Capcom channel. And that's only one of 30 channels, and you're not going to hear most of the data. You might hear 5 or 10 minutes out of a 170-hour mission times 30 tracks. So you're listening to probably less than 0.1% of the audio that's actually there. So all the backroom discussions, all the problems that come up, these are real people who weren't actually trying to speak into a microphone for speech technology. They were talking because NASA just believed that they should record everything that anyone said. And if something went wrong, go back and look why it went wrong. So the purpose of the audio collection was to make sure that they could do diagnostics on human engagement. So if we go to the next slide. Sorry, I can do that myself, sorry. So the Fearless Steps, this was the channels piece there. So Fearless Steps 1, Phase 1, looked at unsupervised development data, and we had that for 2018 interspeech, or 2019, I think. For Phase 2 was supervised development. We had roughly 75 hours of train and development data. Evaluation side was still 25 hours. And for Phase 3, we looked at system generation. Ground truth data was still 75 hours. Evaluation data was a little bit larger, 34 hours, 20 hours in domain and seen channels, and 9 hours of unseen channel data, along with 5 hours of out-of-domain data, which we pulled from Apollo 13. So this shows the global map of labs that have accessed this data. So to date, 250 research organizations from 50 different countries have participated in Fearless Steps data. 350 systems have been submitted from 45 teams over the evaluation process here. So I'm a little disappointed we don't have anyone from Greenland here yet, but we hope to get someone from at least every continent, I guess. So we have a portal here, and I have to give lots of credit to NIST. They really, really helped us this time because we're an academic institution, and as much as we try, we're basically, a couple faculty members and a few students and maybe some postdocs, but NIST knows how to actually project this out well on the portal setup. They've done it for SRE and LRE if you've done speaker or language ID systems. So they helped us dramatically in this. So Omid really worked closely with our team to try and make sure everything went smoothly. So this is the online portal setup, and they use the NIST OpenSat evaluation platforms that make life much, much easier to kind of go through and do benchmarking evaluations. For the Fearless Steps Apollo 11 data set, again, we've been focused on a 100-hour set, and that's to make it easier for labs to kind of do experiments. But if you have it in your heart to kind of go get all the data, certainly for Apollo 11, there's roughly about 10,000 hours. You can download all of that. We have that set up on our servers. Okay, and if you want to try to get data for the other spots, you can pull those as well. So we have lunar landing, lunar walk, and liftoff as the 3 different phases. For the evaluation setups, we have seen data, which is the core data for Apollo 11, unseen channel data, which is some additional channels, and unseen mission data, which was from Apollo 13. Conversational analysis, there's communication amongst roughly about 100 to 200 people during the mission. It's over 7 days, at least for Apollo 11. So there's people taking turns basically every 8 hours. So you roughly have about 350 people that are participating in this event. And the numbers can get high as 450 depending on whether you have people that don't show up for work or sick or something like this. So the numbers can vary. These show some hotspot illustrations, cases where Capcom is talking to, or the capsule communicator is talking to one of the astronauts, and basically there's maybe an issue that comes up. In the Apollo 13 case, this was the astronaut basically saying, Houston, we have a problem, and they lost basically a third or half of their oxygen, which is a problem if you're trying to get back to Earth. So there's some challenges there, at least identifying the hotspots. This was the hotspot data and baseline system that we put together. We try to kind of keep things fairly generic or simple, so this way other teams could kind of try to improve upon it. We weren't trying to, I guess, beat other folks out. So this was a one-dimensional convolutional network with ball-neck system as well. And because of the short turnaround time for this challenge, there wasn't really any teams that could kind of put this system together. So we're kind of hoping that some folks are still working on this now. So I'll just show you some of the results, at least from the various teams. So for speech activity detection, Carnegie Mellon came in first with their submission. Second place team was from China, Duke Kushan University. And third place team was from Spain, from the University of Zaragoza. Sorry, I apologize for the pronunciation there. And that was the Vivo Lab. And for speaker diarization and speaker identification, the team again from Duke Kushan University in China did well there. And for the ASR side, it was the Singapore team that from Infocom research team that they came in first in there for both tracks 1 and 2. These are the sets of results here. So we benchmark all those. They're useful if you're just trying to do comparisons against things. Because of time, I won't go through the details on that. And finally, I just show the evaluation set. So if you're looking at speech activity detection, you can see that in the mismatch case, the similar conditions are when things are green. And when they turn red, it means we've jumped from Apollo 11 to Apollo 13. And one of the things to kind of keep in mind is that this is all analog tape. So they originally recorded on 30 tracks, and each track actually literally has maybe thousands of feet, if not more, of line where the audio is finally coming into one recording spot. So all channels get recorded at the same time. So every channel has dramatically different acoustic conditions. So we can see, at least for the SAD, there's a pretty big shift in the score distribution there. If you were to look at speaker ID, you can see there's a paradigm shift where the speaker, the out of set or out of domain case just goes to a completely different space. For the ASR side, first one looked okay, and there were some good results there. You'll see that it looks like things flatlined in the track 2, and that's because every system that came out on that one produced a null hypothesis. So it was 100% word error rate on that, so pretty easy to kind of improve against that. For the diarization side, also really, really big mismatch on that. So speaker ID, diarization are the ones that had the biggest challenges. So finally, next steps here, we're looking at Fearless Steps 4. The prospects here are to add some additional Apollo missions. We actually have sample data for the remaining missions that I've digitized over the last 3 months down at Houston. And we'll also be looking at a speaker verification challenge as well in collaboration, hopefully, with NIST and LDC. So I want to thank you for your time. If you've got any questions, you can send email to fearlesssteps@utdallas.edu. And please, if you want data, I guess there was an expression, there was no data like more data. This will be flowing in a really big way, so we hope that you'll get access to it and use it to help some of your research work. I'll stop there. Thank you.
Okay, thank you for the presentation.
I'll answer any question except the question is, did we really go to the moon? Because if you're answering that question, I ain't going to answer it.
Okay, there is one question here.
My question was just about the number of speakers in the database. You said, I think if I caught it right, there's 19,000 hours in total of raw audio, but what's the speaker distribution? How many speakers are there actually in the...
Yeah, so when you're looking at each channel, the number of speakers per channel is ranging at any point of time between 3 to maybe 33 people. So you can think of each channel as kind of like a party line, and someone owns each channel, so that's the primary speaker there. Over an 8-hour window, you have one person. So I'll give the example, capsule communicator. So for Apollo 11, for the core parts, a guy named Charlie Duke was the capsule communicator. And so he would talk, for that period, but he's talking primarily to the 3 astronauts, and he's the only one that can talk to them. And you'll hear these Quindar tones that are kind of beeping. And then after the 8 hours, there's another capsule communicator person that comes in. They kind of overlap by an hour to ensure continuity there. So at any one time, you'll have typically at least 2 or 3 people talking. So there's always no one talks just spontaneously. They're actually interacting and getting information. So because of that, there's lots of really good naturalistic data in this. Now, I will also mention some people might think, well, it's really specialized. You're only going to be talking about NASA-type things. But the public affairs channel is also there. And so you literally have all types of commercials from ABC, CBS, NBC News back in the late 60s, early 70s. And all of that is also included in there. And finally, NASA is partnering to have the Artemis project, and that's basically to send someone to Mars. And so they're going to be having a way station on the moon, and it's going to be in one of the locations where Apollo actually landed. So there's a lot of interest maybe going back and looking at how we got to the moon then, because we're going back to the moon, but probably some company, maybe Amazon or somebody, going to be delivering food, water, and supplies to a depot on the moon fully automatically with no humans in there. But at some point, someone's going to fly there, pick up all that stuff, and then head to Mars. I think that's the long-term goal. So.
Okay, thank you. Are there any other questions?
Aditya, are you online? Can you acknowledge yourself if you're there?
Yes. Hi, I'm here.
Excellent. Okay.
I just answered the question which was asked. So, like, just some additional information.
So I think we already answered that previous question. That was just the number of speakers that were on. So.
Yeah.
Any other questions that folks might have, either online or in the room?
There is one.
Yeah, by the offer.
So I have one question.
Yes.
Which text corpora are usually used for language modeling in this challenge?
That's good. I know the answer. I'll ask Aditya. Do you want to answer that? The question was, what text corpora is being used for the language model in the lexicon?
Yeah.
Fisher and Wall Street Journal have been tried before, but to no avail. What has worked is our own collection of about 4.2 billion words, which were scraped off of technical documents from like NASA and other technical sources. And using that, we've created our own language model.
And that's given away. Everyone gets that. So.
Okay, thank you.
Okay.
Are there any other questions?
Yeah, one short.
One short question. We have still time for one short question.
Otherwise, I have one question, short question. So the ASR is faced with an enormously poor signal sometimes, and amazing use of specialized code all the time.
Yeah. So if you look, most of the communications that takes place in NASA and Mission Control, the nice thing is that they're all using the same headsets. So if you look across, maybe the 10-year window or so, they're all using the same headsets, which is good. But there's handsets and a variety of other communications. If anyone ever saw the movie Hidden Figures, book written by Margot Shatterly, her dad actually was a NASA scientist in the 60s. Not an easy thing to do when you're African American, but he worked at NASA Langley. And so there are connections between NASA Mission Control in Houston and roughly about 8 other locations across the U.S. And the other weird thing that maybe you don't think about this, but when you're talking from the moon to Earth, you can't whip out your satellite cell phone because it doesn't exist. So there's literally, I think, 6 or 7 listening stations. They're basically parabolic dishes that capture the audio. One was Madrid, Canary Islands, Goldstone in California, 1 in Australia, Cripple Creek, I think is what it was. I can't remember. But all of those audio then got rerouted to Houston. So you can think of all these delays and things that are coming from the moon. And these were pretty big engineering challenges because no one figured out, well, how do you send audio data and video from the moon to Earth in 1968 or 69? I mean, you got to realize you didn't have the technology we have today for that. So, okay.
Yeah. It's all very interesting, but I think we have to conclude this session by,
Okay.
by
Thank you very much. Thanks.
yeah, by thanking the speaker again and all other speakers. So thanks, John.